Hey guys, and welcome to the bonus notes. So these bonus notes are supposed to be an extension of what we were doing today. Today we are really focusing in on negative exponents because we just did zero exponents in class. So the purpose of this video is to go over negative exponents, which we were not able to get to today unless you were watching this video. So we're going to start with this do now. I hope that you'll take a second to look at it. I know it's kind of hard to see on the dot cam, so I'll trace over anything I think that's important. So if we look here, scholar A and scholar B were given the exact same problem, which is 6a squared b squared over 18a to the fifth times b. So remember that fraction bar means dividing. So keep that in mind as we're going. In scholar A, when they simplified this, they got 1 a times a to the negative third times b over 3. Scholar B, for the same problem, got 1 times b over 3 a to the third. So if we're looking here, the only difference I see between these two answers is that over here, this guy had an a to the negative 3. This guy over here had an a to the 3. So if we look, my exponents are different. I had a negative 3 over here, and I had a 3 over here. But if I look again, I notice that there's one more difference. I had an a to the negative 3 on the top, or in my numerator, and my a to the third was in the denominator. So to answer this question, whose work is correct and why? Both are actually correct. Both are correct. Scholar B is more correct. And let me tell you why. So when I have a negative exponent, what that means is that I can flip it over my fraction bar to the bottom. So if I have an a to the negative 3, I flip it over my fraction bar. So it goes from the numerator to the denominator, and my negative exponent becomes a positive exponent. And the reason that scholar B is more correct is that we don't like to see negative exponents. So when we're thinking about simplifying, it's not fully simplified if I have a negative exponent. So scholar B went that last extra mile. They saw what should have been a negative exponent, and they just flipped it over to the bottom. So scholar B is more correct because fully simplified answers do not have negative exponents. So both are correct. For today, on your exit ticket, I'll accept either one of these, but scholar B is more correct because fully simplified answers do not have negative exponents. So I'm going to move on to their exponent rule. To make a negative exponent positive, you have to move it to the other side of the fraction bar. So that means that if I had a fraction, if I had a negative exponent on the top, I would move it to the bottom. If I had a negative exponent on the bottom, I would move it to the top. So let's write this in symbols, which is kind of what I did over there. But let's say that I had a to the power of negative n. So remember, I can fill in any number in the world for a and any number in the world for n. This would be the same thing as saying 1 over a to the power of n. So two things to notice here. Number one, if I don't see a fraction bar, I can assume that it's on the top. So we can kind of draw a line underneath. I can assume this is on the top. So I see a negative exponent. I flip it over my fraction bar to the bottom, and my negative n becomes a positive n. That's just what a negative exponent means, is that you're flipping it over to the opposite side. So looking at example number 1, I had k to the negative 6. So I see a negative exponent. I know that means I have to flip it over my fraction bar, and it gives me 1 over k to the power of 6. I'm going to let you guys try these two on your own. Again, the answer key is at the wall over next to the calculator. So if you want to check to make sure you did it right, with those two, please check your answer key. Other than that, I'm going to move on to here. So for example 2, it says simplify. This time I see 2 negative exponents. So I'm going to circle my negative exponent at the top. I know that means I got to bring it to the bottom. My negative exponent on the bottom, I know that means I got to bring it to the top. And then I'm left with this little 3. So this 3 right here, do I see any exponents on my 3? Nope, I do not. So my 3 is just going to stay put. My 3 is just chilling in the numerator. But I have this w to the negative 4. I know I got to bring that to the denominator. So I'm going to write my w. And when I bring it down, my negative exponent in my numerator becomes a positive. So my w to the 4th is going to be in my denominator. I still have this y to the negative 2 that used to be at the bottom, but I see a negative exponent, so I know I got to flip it over that fraction bar. So I'm going to bring my y up, and instead of a negative exponent, when I flip it to the top, it becomes a positive. So my final answer here, when it's simplified, is 3y squared over w to the power of 4. I'm going to, again, let you guys try these two on your own, and then make sure you check your work if you want to. Example 3 is probably the trickiest one here. And remember, you can always pause the video if I'm going too fast. So example 3 is probably the trickiest one. There's a couple exponent rules I have to remember here. Here I look, remember this dot right there means multiplying. So if I'm thinking back to when I learned about multiplying, I remember that we had 2 steps. Step 1 was multiply coefficients. Remember, the coefficient is that number in front, so this would be a coefficient. Step 2 was multiply my variables. And what do I have to do when I'm multiplying my variables? I add my exponents. So when we're keeping that in mind, let's not forget that. So when I'm multiplying my coefficients, I'm going to bring that off to the side. So I had a negative 2 in front of my x, and then I had a 7 in front of my x to the negative 3. So when I'm thinking about what my answer is going to be, actually, I'm not going to draw that box. Negative 2 times 7 gives me a negative 14. Over here, I'm next going to look at my variables. I see I have an x times x to the negative 3. If I don't see an exponent, my invisible exponent's a 1. So when I'm multiplying x times x, x is my base. That base stays the same. I know I got to add my exponents. So 1 plus negative 3 gives me a negative 2. Last step, I got to look at those y's. So I have y to the negative 2 times y to the negative 3. When I multiply, my bases stay the same, and I got to add those exponents. So negative 2 plus negative 3 gives me a negative 5. So my final answer right now is negative 14, x to the negative 2, y to the negative 5. But if I'm thinking here, is my answer fully simplified? No, it is not. So I have to flip my negative exponents. Flip my negative exponents. So let's go one term at a time. I'm going to set up my answer box and my fraction bar. Does my negative 14 have any exponents? No, it does not, so it's going to chill in the numerator. My x to the negative 2, I see a negative exponent, and it's on the top, so I know that means I got to bring it down. So my x squared now, because my negative becomes a positive when I bring it down to the denominator, it's going to stay like that. And then I have y to the negative 5th. So my negative 5th power, I know I'm going to bring it down to the denominator as a positive. So my final answer is negative 14 over x squared times y to the 5th. So this is my final answer right here. Good. There are some practice problems at the bottom for you to try on your own. Remember, if you get stuck, we're going to follow these steps. The answer key is, again, going to be on the board. I'm just going to do one more example for you with the quotient rule. So again, pause here, pause, and practice these. This will be the answer key over there, but pause and practice right now before you move on to me going over example 4. So last example I'm going to do with you, the rest of these practice problems. Remember, if you turn in these practice problems, it counts as a homework pass. So I'll make a note and it will be a free homework for you later. I'm going to rewrite the problem over here to the side. Oh, wait, there it goes. Never mind. I can see it now. I'm going to look at this problem right here so that we can make sure that we are understanding this practice. So what's different about this guy right here is that instead of multiplying, I'm now using my quotient rule. So the same thing stands. Number 1, instead of multiplying my coefficients, I'm going to divide my coefficients. And then step 2, I'm going to divide my variables. And what did I just learn today? When I divide my variables, that means I have to subtract my exponents. Good. So let's take it one step at a time. I'm going to look for my coefficients. If I don't see a coefficient, my invisible number in front of my variable is a 1. So I'm going to do 4 divided by 1. That gives me 4. So I know my coefficient is going to be a 4. So next, let's look at these h's. So I had h to the negative 3 over h to the negative 2. So when I am dividing, I know I subtract my exponent. So I'm going to have h to the negative 3 minus negative 2. You and I both know that when I have minus and negative, that becomes a plus. So I'm going to do negative 3 plus 2. That equals negative 1. So far I have 4, h to the negative 1. Next, I'm going to work on those j's. So I'm going to have j to the negative 3 over j to the negative 4. I know that when I'm dividing, I have to subtract my exponent. So I have negative 3 minus negative 4. You and I both know that minus and negative becomes a plus. So that leaves me with negative 3 plus 4, which equals 1. So I have j to the power of 1. So I have my 4, my h to the negative 1, I have my j to the 1. Lastly, I'm going to take care of those k's. So I have k to the negative 1 over k to the negative 2. I know that when I'm dividing, I subtract my exponent. So I'm going to do negative 1 minus negative 2. Again, minus and negative becomes a plus. So I'm doing negative 1 plus 2, which equals 1. Remember, you can do that in your calculator. So I have k to the 1 as well. So when I bring it all together, I end up with 4, h to the negative 1, j to the 1, and k to the 1. I got to look for any negatives, so I'm going to flip any negatives. So flip any negative exponents. And let's look. Does 4 have a negative exponent? No, it does not. It's just a 4. So I'm going to put that up here in my numerator. This is going to be my answer. I see here my h has a negative exponent, so I know that means I have to bring it to the bottom and keep it as a positive exponent. So I have 4 over h to the first so far. My j and my k both have positive exponents, so I'm just going to bring them over. So I have 4jk over h. So 4 times j times k divided by h. And that is my final answer. So that's the last thing I'm going to go over with you all. Some of these get pretty complicated, so take it one step at a time. For me, I still sometimes break it up by letter like that and then bring them together at the end. So I took all of these and I brought them together at the very end. All answers are going to be on the board. If you have any questions, please let me know. But for now, it's up to you. Check those answers and get that homework passed. Thanks, guys.